In the last video of this unit, we're going to give a conclusion. So in this part of the video, we have first started with analyzing the roofline model by comparing the capability of a GPU and the requirement of the workload. By making the comparison, we can basically classify a workload as either memory intensive or compute intensive, and that provides some guidance about how we can optimize the program. We want to optimize the program so that the arithmetic intensity of a GPU program to be similar to the arithmetic intensity of the GPU. And then we focused on memory coalescing. So then we talk about memory coalescing. We talk about the performance impact of memory coalescing. We can see the performance can be significantly improved if we convert a non-coalescible memory access to coalescible memory access. And then we use the matrix transpose example to discuss how to use LDS to convert a non-coalescible memory access to coalescible memory access and to improve performance. We also talk about tiling. Tiling applies to both matrix multiplication and matrix transpose examples. And by using tiling and LDS, we can reduce repeated memory access and also convert a non-coalescible memory access to coalescible memory access. So as an assignment of this unit, I want you to be able to implement the image convolution algorithm. It's a building block for a convolutional neural network. If you implement this algorithm, you can start with the naive version by calculating the output using one thread to calculate each output element. Then, as you can see, and you can try to use ROC-Prof to profile the program and see what's the performance issue. Is it a compute-intensive or memory-intensive workload? And you can also analyze if the memory access is repeated or if the memory access is non-coalescible. And as you can see, this image processing workload is very natural for you to consider using tiling method. So can you use tiling method to improve the performance, reduce memory access, and reduce the non-coalescible memory access? You can profile your result to see the performance improvement. And finally, in the next video, we're going to start to talk about another way to improve the GPU performance, especially when we run well-established algorithms. And in Unit 9, we're going to introduce heap libraries to see how we can use libraries to avoid repeated development and to improve performance.